Hello, everyone. Am I audible to all of you? Okay, so good afternoon to all of you. So today again, I am going to discuss the subsequent topic of process dynamics and control. So in the previous lecture, I was discussing about stability criteria and how we can understand the stability criteria. And that was with the help of Routh array. And we were forming the Routh array and we were observing the sign of the coefficient of the Routh array, right? That we have done this particular thing, and from there we were telling about that whether the system is stable or not. And it's one of the you know very frequent method to understand or to analyze the stability of a closed loop transfer function. The reason behind that is you only you have to only solve the closed loop transfer function and you'll get a polynomial in the S domain, and while observing the coefficient of the polynomial in the characteristics equation, if this is the characteristics equation here, so if all sign of all the character, I mean coefficient of the characteristics equation is positive, then the system will be maybe stable and may not be stable. But if any of the coefficient is negative, then the system will be certainly unstable. So that was the criteria that I have discussed in the previous lecture, and after that I have you know discussed with you how we can that a1, a2, a4, this a term will be given in the problem, and we can calculate this coefficient of in terms of a1, a2, or a3 in a domain, you can say, with the help of this characteristic equation. And after that, to make the Routh array, we have to calculate the value of v1, v2, v3, c1, c2, c3, e1, e2, f1, g1, and all, so and so forth. So we have calculated the value of b1, b2, c1, c2, e1, e2 with the help of this particular formula, right? So till now we have discussed we have studied all these things, and after that I was telling the element of the column first, that is a note a1, b1, c1 should be positive for the system to be stable. That already I discussed this array in the first column. If all the coefficient of the column first is positive, then the system will be certainly stable. And when if there is a sign change in the column first, if there is a sign change in column first, then the number of sign change will tell you the number of positive roots lies outside of the uh, you know in a complex plane. So again, this was very important. So here I have told you, here this 4 is minus, so here 7 is positive. Positive to negative one sign change, again negative to positive second sign change, and again positive to negative third sign change. So here you have observed that three sign changes are there. So if a system is if the characteristic equation is like that, something like that, and if three coefficient is negative, I mean if there are three sign changes are there, then these three roots of the characteristic equation will lie in the complex plane of right side. That's why the system will be unstable. I have discussed these things. And next thing I have discussed with you all, that all these particular things, if roots lies over here, then the system will be unstable. If roots lies here, system will be stable. If roots lies here, system will be stable. And if root lies here, system will be unstable. So if root lies in the third and fourth quadrant, sorry, second and third quadrant, definitely the system will be stable. And if roots lie in the first and fourth quadrant, then roots will be unstable. Now, one more thing I had discussed about that, that if root lie on the imaginary axis, let's say here, root can be here only. The real part of the complex number will be zero, then that root will lie on the imaginary axis only. So if root lie on the imaginary axis, then the system will be marginally stable. So you can write if roots lie on the imaginary axis, then the system will be marginally stable, right? So this was the case that I have discussed with you all. Now today, let's try to form the Routh array first, and after that we'll move forward to the some new problem today. So let's say there is a problem. Let's say let S4 plus this one is 3s square plus 3SQ, I think it should be 5s square plus 4s plus 2 is equals to 0. So now this one is your characteristics equation. So now how can I make the Routh array? So I have told you this will be a Routh array kind of thing. So in the first I'll be putting it. So you can write this in terms of this one. These characteristics equations can be written as, let's say, a naught s to the power 4 plus a1 s to the power. I mean, just try to follow one method. Let's say here I am writing a naught s to the power n plus a1 s to the power n minus 1 plus a2 s to the power n minus 2 kind of thing, right? So that's what the thing I am writing here. So a naught s to the power q plus a2 s square plus a1s plus a naught s to the power 0 is equals to 0. So now here there is a naught a2 and sorry, a naught a1 a2 a3. It should be a3 and it should be a4, right? So what I told you that I'll be writing here a naught a2 a4, right? Here I'll be writing a1 a3 a5, and if I will be writing b1 b2, here I'll be writing C1, C2. I can calculate B1 is equals to what? That A1, A2, A2 minus A naught, A3 divided by what? A1. Again, I can calculate B2, B2, that is A1, A4 minus A naught, A5. I'll be calculating A1, A4 minus A naught, A5, and again divided by A naught, A1. C1, C1 I can calculate B1, A3 minus A1, B3. So I can calculate, yeah, sorry, B1, A3 minus A1, B2 divided by B1, and I can calculate the value of C2, that is equals to B1 A5. If there is nothing, then it will be 0. I can write B1 A5 minus uh, B1 A5 minus A1 0, A1 into 0 divided by your B1. So this will 0, this will be 0, so that will be A5. Fine. So we have calculated the value of C1 and C2 all. So now, what is value of A naught? A naught is what here? 1. So I can substitute here 1. So I'll be removing all these things, and I'll be substituting the numeric value over here so that I can solve the problem. If anyone has any doubt, you can ask me, right? So your A naught is 1, A2 is what? 5, and your A4 is again 2. I hope these things is clear to all of you, right? And now your A1 is 3, your A3 is 1, or sorry, 4, this one is 0. Now this one is C1, so C1 is your B1 A3, right? B1, sorry, B1 we have to calculate. B1 is equals to A1, this one is A1 A2 minus, so 15 I can write here, that is your 3 into 5 minus 4 into 1 divided by your 3. So that is equals to 15 minus 4. That is 11 by 3. Now your B2 is A1, A4. So this one is your A1, A4, that is 6 minus A naught, A5. A naught, A5, that is 0 divided by A1. A1 is 3. So that is equals to 2. So we have calculated the value of B1 is 11 by 3, and this one is 2. I hope this thing is clear. Now, next is we have to calculate C1. C1 is B1 A3. So B1 A3, C1 is B1 A3 minus A1 B2. So that is 44 by 3 here. 44 by 3 minus A1 B2, that is 6 divided by B1. B1 is 11 by 3. So how much you will be getting? 18. If 44 minus 18, how much? 22 plus 2, 24. That is 24 divided by 3, right? And divided by 11 by 3. So this will get cancelled out. So it will be equals to your 24 divided by 11. And again, what is A5? So A5 is nothing, so 0. So now this one is your first row, right? Here you can see this one is your first row, and all the coefficient in this first row, that is a positive, right? So if all the coefficient in this first row is positive, then the system will be your stable. For second thing is that we would have understood that system is stable or unstable. Definitely, the system is if all the coefficient here is positive, then system may be stable, may not be stable, right? So if you understand if system is maybe stable, may not be stable, you have to make the root array, right? But if let's say if here be the if it is positive, if in place of positive, if the sign would be negative. So while observing this characteristic equation only, you can see the characteristic equation, and here there is sign that is negative sign, then system is unstable directly. But if it is positive, then the system may be stable, may not be stable. So we have to make the route array, and after that we can solve this particular thing, right? I hope this thing is clear to all of you. Anyone has any doubt? So this may be one kind of problem, and another kind of problem may be like that. So they can give you some this kind of row, that is 1, that is 11, that is 6, that is 6 into 1 plus Kc, 10 minus Kc, that is 0, and they'll give you 6 into 1 plus Kc. So they are telling you that I mean there is a character, there are a character. I mean uh, a closed loop response system is having a characteristics equation something, and from characteristics equation we have formed a route array, and we want to understand if the system is stable, then what will be the value of maximum value of Kc, so that system will be stable. So if this system has to be stable, what should we do? We can do that the coefficient of all the first row should be positive. This one is positive, okay. This one is positive, okay. This one has to be positive. So first, what will happen? 10 minus Kc should be greater than 0. So minus Kc should be greater than minus 10. So your Kc should be less than 10, right? So I have got this one. Now this coefficient has to be positive also. So can I write 6 into 1 plus Kc should be greater than 0. So 1 plus Kc should be greater than 0, and Kc should be greater than minus 1. So we have got Kc should be less than minus 10 and 10 here, and Kc should be less than minus 1. So the value of Kc here, let's say 10, here let's say 0, and here let's say minus 1. So the value of Kc should lies in between, then this particular system will be stable. So the maximum value, the Kc, the range of Kc will lie over here. So this range will give you the stability of the system. That if we are substituting any value of Kc in between minus 1 to 10, then this system will be stable. So sometimes they will ask you to calculate the range of Kc for which the closed loop response will be stable, right? So this is the way that we can solve this kind of problem. Anyone has any doubt? Hmm. I hope there is no doubt. Then I'll move forward to the some different kind of problem over here. So again, this one is very important kind of problem. Every year, get people used to ask some questions from here. So let's say SQ minus 3s square plus 11s minus 11. I don't know what they are writing. That is equals to 0. So we have to you have to tell whether the system is stable or not. Darshana, is this system stable?
It's unstable.
What stable?
Unstable.
This one is unstable. Why? Because here you see there is negative and there is negative. So two coefficients are negative. So system will be your unstable. But if it is positive, then what will happen? You have to make the route array. And once you make the right route array, and from there you can get all the coefficient, and you have to observe this coefficient over here. If any coefficient over here is negative, then definitely system will be unstable. And how many roots are there lies in the right side of the complex plane. So you can understand that number of sign change from here to here kind of thing. Is there any doubt? So if it is clear, then let's try to solve one problem, right? So this one is your Kc, right? This is a closed loop transfer function. And let's say this one is 1 upon s plus 1, right? So this one is your output product, sorry, output, and there is a feedback system over here, and the value of measuring instrument is 3 upon s plus 3. Fine. So again, it will come to the comparator. It will get compared. This is zeta. This is your x, let's say input. That is your set point. Okay, fine. So we have to understand whether the system is stable or not. For first, Kc is equals to, let's say, 9.5. Second, Kc is equals to 11. And when the value of Kc is 12, we have to understand whether the system is stable or not. So first, when we try to understand the stability of this particular system, we know we have to make the transfer function. So transfer function Gs, that is equals to C upon X. So I can write directly that Kc into 1 upon S plus 1 upon 1 plus Kc into 1 upon S plus 1 multiplied with 3 upon S plus 3. So now I told you that the denominator of the transfer function will becomes your characteristics equation. The characteristics equation is equals to 1 plus 3Kc divided by S plus 1 into S plus 3. So finally I can write S plus 1 into S plus 3 plus 3Kc, right, divided by S plus 1 into S plus 3. That will be equals to 0, characteristic equation. If you want to find characteristic equation, so can I write S plus, that is equals to S square plus 4S plus 3 plus 3Kc, that is equals to 0. So this one is your characteristic equation. Now, once we get the characteristic equation, the main aim is to make the Raoult array. So first try to see here, once you get the characteristic equation, here you see there is a positive, all the coefficients are positive. So directly we cannot say the stability and instability of the system now. If any of the coefficient would have been negative, then we could have told that, okay, this system may be, I mean, this system is unstable. But here all the coefficient is positive, so you'll have to make the Raoult array. So the system is your s square plus 4s plus 3 plus 3Kc is equals to 0. So how can I make the Raoult array? So I can tell s square plus 4s plus 3 plus 3Kc. This one is equals to 0, right? So now, I mean, either you can tell it directly, right? 3 plus 3Kc. Here the coefficient is 1, it is positive. Here the coefficient is 4, it is positive. So this coefficient should also have to be positive. Then the system may be stable. So you can directly calculate here 3 plus 3Kc should be greater than 0. 3Kc should be greater than minus 3. So Kc should be less than minus 1. Are you getting it? So the maximum value of Kc should be minus 1, then the system will be stable. Now, the thing is that you have calculated this particular thing, or you can calculate from this Raoult array. So you have to make Raoult array. So this is equals to A naught S square plus A1S plus A2 S to the power 0 is equals to 0. So here I will be substituting A naught, again A2, and here this one is A1. So the value of A naught over here is your 1. Value of A2 is equals to your 3 plus 3Kc, and the value of here, this one is your 4, right? So this will be 0. Now, if I want to calculate this value over here, so this one into this one minus this one divided by this one. So it will be equals to 3 plus 3Kc, and this will be 0. Fine. And here it is 0. So now, if we have to find the stability of the system, we have to understand that all the roots of the, I mean, all the sign here is positive. This one is positive, it's fine. This one is positive, it's fine. But here you see there is 3K plus 3Kc. Now the whether this particular thing is positive or negative, that depends upon the value of Kc. So I can write 3 plus 3Kc should be greater than 0. And similarly, I have got these things here from directly here, right? So that's what the case is. So 3Kc should be greater than minus 3. So Kc should be less than minus 1. So if the value of Kc is less than minus 1, here minus 1, minus 2, and 0. So for all the value of Kc which is less than minus 1, the system will be stable, right? So now we have asked that if Kc is 9.5, Kc is 11, and Kc is your 12, whether the system is stable or not. So for all the value of Kc here, that is given 9.5, 11, and 12, the system will be unstable because Kc should be less than -1 for the stability of this particular system, right? So this is, I mean, this is one of the way that they will be asking you the stability of the system, for a closed particular closed system. So I hope you people can solve this particular problem now. Anyone has any doubt? If there is no doubt, then you people solve one question from here. So one more question that I'm going to give you, that is S4 plus 6s cube plus 4s plus 1 plus k is equals to 0. Now find the value of k for which the system is stable. Just try to find out here. I'm giving you 2 minutes time. Just try to solve the other.